I wanted to remind all of you, okay? This is a time series data. So far, we haven't learned anything about time series, okay? So with all this result, it's based on what we have known, okay? And if we see, if this is, especially this is a time series data, and there's important statistics we have to know is this one. It's called Durbin-Watson statistics, okay? And look at all this result. The Durbin-Watson statistics is very small. Okay, now how do you know this is small? Okay, this is the professional knowledge. Okay, you haven't learned it before, but next semester, if you take the course, which we will deal with all this time series data, and this one is the important statistic you have to notice. And with the Durbin-Watson statistics like this one, tell us the original data does have positive relationship. Serially correlation. We haven't said anything about that this semester yet. Okay? And according to the Durbin-Watson statistics, this one is positive serially correlation. And we need to deal with this problem first before we, really refer to the result of those hypothesis testing. So this is another problem we need to deal with before then we read all this result. So there's another branch of the knowledge. You have to understand it because this is all time series data. Okay? And if you just use this data, then report the result like this one, then you're going to have trouble because this is real bad numbers in terms of time series data. So you're not able to use this as the final result, because we didn't deal with any time series problems, okay? And these numbers tell us there's a serious time series problems. Okay, I'm just using examples to show the relationship like this one. Okay, so do not report this one as the final output. Okay, since we haven't done the problem, deal with these problems of time series data yet. Okay? All right. I like to show any other examples too. Well, let's see. Let's look at quarterly sales. This is also a time series data. Okay? Okay, look at the data, something like this. Look at this. This observation is from 1986. Okay? This 1, 2, 3, 4 is about the first season, second season, third season, and fourth season. So this is a quarterly data. Okay? This is quarterly data. And the Y is the sales. And X, we have two X variables. One is called real personal disposal income. Real personal disposal income. And this is the confidence, numbers. Confidence numbers. And D2, we have, since there's 4 seasons, right? This is the second season as a 1, third season as a 1, and fourth season as a 1. And using the first season as the reference group. So it's the comparison group. So since there's a 4th season, we just need 3 dummy variables. The one we just have it is 1 dummy variable, which is before recession, after recession. Now it turns out to be the quarterly data. So I need to have 3 dummy variables to identify the different seasons. Okay, so this is also a useful way to check with the seasonal effect for the cells. Okay, so I think, especially maybe you're working with some kind of marketing or something. So you need to know whether the product has any seasonal effect. And dummy variable is also a useful tool. And here, not only one, but also 3, because we have 4 seasons. Okay? All right. So let's run this one. Okay? I'll see what we have. Okay, first of all, run cells, and this 2x. Okay? Then run cells 2x with 3 dummies. Then, since I have 3 dummies, each one of the dummy was 2x. Understand what I'm saying here? This is called x1, x2. Then this d2, d3, d4. Then using d2 times this one, I didn't do it here. You have to do it by yourself. Okay? d2 times this, d2 times this one, d3 times this, d3 times this, this times this, this times it. So do it here first, Excel, easier than doing in Excel, then do it in the Gradles. So do it first, okay? Then import it to the eViews, then run the regression. Understand what I'm saying here? So you need to add more 6 variables, which is the interaction of individual D with 2 x's. When you work your thesis, this is, you started from your data first. And usually we work with our data using Excel. It's much easier and faster. And after you have done all the data, then you import it to the eViews and do the regression analysis. Yes?
Once we graduate from TUSC, we won't have free access to eViews anymore, right?
In the eViews?
After we graduate from TUSU, we won't have access to eViews for free, right?
It's impossible. It's not possible since you are not students anymore. This is campus license.
Like if we come to a point we need it in our professional life, will the company have to provide for it, or do we have to find alternative software?
Well, for software, if you do it in your job, I think maybe your company will provide you. I don't know.
Okay.
Yeah, I don't know.
I just asked out of curiosity.
It's really
Because that's interesting, and that can be useful maybe.
and convenience, right?
Yeah, that's really convenient.
Yeah, but this is like, this is copy. There's always have a copyright,
Yes.
and this is the copyright. So, and this is campus license. Therefore, if you are students in this school, in a professor in this school, we can use it. And also, I know all of you that off campus, you need to reconnect it after every 2 weeks. Have you bumped into these questions? I didn't really bring my laptop in school, so I have to bring it after 2 weeks to have this connection. Then I can use the license, eViews continuous. Otherwise, I cannot use off campus either, even you are students,
Yes.
since this is campus license. Okay. this is what I run, okay? First of all, for the season vectors, okay? The second equation is for seasons with individual x, and the third one is the seasons in individual x with the interactions. So this is. Let's see this one. Do you have the same result as I did? This one and this one. You know, this is the way I do it in the eViews instead of Excel. I can do it in the eViews too, but I have to type it this one by myself in the regression and in the regression analysis. Okay, and I think that's you know, maybe I do it in Excel is much easier than I do it in Excel in the eViews. It's better to run it by yourself than check with my answers. Is it the same? Okay. And you know, this kind of practicing is very useful to train yourself, especially, you know, when you do your thesis, you have to do a lot of work like this. Okay, what? Okay? Huh? In the eViews?
Yeah.
You mean the third one?
Yeah.
Okay, you highlight Y and all the X. And yeah, what's an equation? Okay, then add d2 times this. Right, this one. Then d2 times RPDI. And do it one by one. So I say that it's easier to put it in the Excel. Then import it, then do it here, right? You all get a result? Like what? Like what I have on the board? Have you done it?
Yeah, I think I got the exact same. Just I don't know why there was this 8, thing like here and not the actual times. I don't know why, because in my Excel I put actually time, but
Oh, no. Excel, you should use this,
the X.
like
Right.
this. What is it?
We
Where
can
is
use just X. It looks like the times.
it? In Excel?
Yeah, I mean this.
No, use this one.
Yeah, I
Yeah.
know, but when I click here on Excel,
It works?
automatically- Yeah, it was.
Oh, good. Then good. Okay. Okay.
But the results are good.
Yeah.
It's not here. You see, it's not displayed as a X.
Ah.
That's what we would expect.
Okay.
That you do. I don't know why.
Well, I do it in the eViews.
Oh.
I do it in the eViews. I didn't do it in Excel.
Okay.
But I recommend all of you to do it in Excel. Okay, what did you see from the result here? First of all, does the seasonal effect important? This is all seasonal effect, right? Does the seasonal effect important? Yes, it's all significant, right? And from the first output, the C, the constant intercept, is working as a first season, average sales of the first season, because I don't have any X variables, right? And the second one, what's the 14.996 means? Yeah, what does that mean? You don't. Well, let me write on here. Anybody knows? Nobody knows. Well, let me write down here. So again, this is the magic of math, all right?
I'll take the quarterly amount of sales for 1 year.
Is 2, beta 2 is D3, and beta 3 is D4. This is what we have.
Yes.
Okay? So when D2 equal to 0, equal to 1, what does that mean? If D2 equal to 1, these 2 are 0, right? Because this is only for second season. Right? If D2 equal to 1, means Y equal to beta 0 and beta 1. This all 0, right? When this is 2, okay? Let me write it down clearly. D3 equal to 1, Y is beta 0 plus beta 2. D4 equal to 1 is Y equal to beta 0 plus beta 3. So can you explain what's the coefficient of the beta B1, beta 1, which is 14.69? Can you explain it? This means when D2 equal to D3 equal to D4 is 0, means what? Y is beta 0. So this is the first season sales. Okay? So this is first season.
So the first quarter, right?
So what's the beta 1? Yeah, quarter. 4 quarters. So first season, right? So beta 1 is what? What's the beta 1 means?
It's the impact of the second quarter of sales on the slope coefficient.
right? So beta 1 here, 16.9. 14.69 means what? The extra cells for the second season besides the first season. So the first season is 73. So the second season will be 73 plus 1469. So it's something like 15 more than the first season. Okay? So every one of them is compared with what? The first season. They all compare with the first season. Therefore, we say that D2 equal to 1, D3 equal to 1, D3 equal to 1. All stands for their own season, second, third, fourth. But how about the first season? It's the comparison group. All of them compare with the first season is the meaning of the coefficient. Okay?
Here the coefficients for D2, D3, and D4, are they like because I'm thinking like accountants kind of. So is this like for instance D2 we have 15. Is the coefficient 15 the average value of one cell in quarter 2, or is it
It's the extra
so
cells
compared to
quarter 1.
So if
is
we just look at that, we can now that quarter 2 has been better than quarter 1, quarter 3 has been better than quarter 2, and quarter 4 has been better than all the quarters.
Yes, and all the coefficients getting bigger, 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 right? So the fourth quarter is the big season for these cells, right? Isn't that interesting? Can this apply to your thesis in the future? Maybe you can, you have to start with, start thinking of your thesis, right?
Well, thinking very hard right now.
Thinking very hard. Good, very good. Okay, so the first one is just using the season as a factor. But, the factors affect cells is not only season, but also two important X variables, which is real personal disposable income and also the confidence index. Okay, so these two tell us that if I add these two variables to explain the variation of the cells, these two shows the positive relationship. It means that I have the real disposable income increase, then sells more, right? Positive relationship. And I have more confidence level or confidence index, then means I have more confidence. Then the sales increase. So all positive. And it is very significant. Okay? And with this 2x extra numerical variable added, these 3 seasons is still important, significant, and the numbers is not much change with the original one. Okay? So season factors is important too. All these dummy variables can be considered as a one dimension called season effect. And this is one dimension called income effect. This is called, one of the dimension is called confidence, index. Okay? All right? And they are all significant. Then how about this? We're doing with all these seasons with these X variables. So if I work with this one, those D is called intercept dummies, right? This all called intercept dummy. This is also intercept dummy. They all affect the intercept only. But with the interaction terms, there's a slope dummy. And can you tell me what's the meaning of those slope dummy?
So
There was
your question is still unanswered, or?
nobody answered. No. I'm waiting for your answer.
What we get for D2 times RPDI, D2,
Uh
CONF, and all the rest
huh.
is so the actual variable that we made out of the first variable and the dummy variable,
Mm-hmm.
or slope dummy variable, is the actual impact. For instance, D2 times RPDI, the impacts of D2, so second quarter sales, like on the total sales, when RPDI is true. And same for CONF.
Mm-hmm.
The impacts of D2 when CONF is true. And we got that for all the four other
Yeah.
slope dummy variables.
Yeah.
Actually, I don't know what RPDI and CONF are, so I can't really
Okay. This is called confidence
confidence.
index. Means
Oh, okay.
do you have any confidence in the market
Oh, okay.
or economy, something like this one? And this is the real personal income, disposal income. So one is personal disposal income. So this is called the income effect to the sales. This is the confidence to the market or to the economies.
So, for instance, we get the second quarter sales when the confidence here is like, when it's true, it means positive, right?
This one means that if I have more confidence,
Yeah.
then the sales is increased.
What,
This is positive, right? And this, again,
Here we can see that actually it has a negative impact
mm-hmm,
on the second quarter sales, right?
mm-hmm,
We get a negative 0.3,
mm-hmm.
well, 0.25, like, let's say 0.3. Maybe, and so from that we can like relate that back to the theory. We could say
Back to the what?
to the theory. maybe.
Theory, okay.
We say like if people are very confident for the market, maybe I don't know, they expect prices not to be as high or as they are right now, or they get interested in other companies because other companies are also doing good. And so we tend to have less sales because customers get interested in other areas of the market instead of just your company.
Yeah.
That's an idea. Probably probably not the best explanation for that.
Well, all the seasonal factors, if we do this interaction terms, means that all this confidence index or the personal disposal income related to the season, right? Because we times each individual X variables to the season. Means that we know that seasonal factors affect the sales. We know these two individual disposal income affect the sales. We also know confidence index affect positive affect sales. But all this disposal income related to the seasonal factors, whether the confidence interval related to the seasonal means that do we have different confidence level index with different season, or do we have disposal income with different season? And the result tells us is like this. So what is this result? This output tell you. I said again, the last quarter means D4. D-
D4 seems less impacted in terms of the coefficient because it's all sales, so we can kind of compare the coefficients.
Uh-huh.
Right? Because the variables are actually the same. They are not the same time, but they are the same things. All the sales from the same company from the same year. So we can, I think it's okay to compare a bit. So D4 times LPD and D4 times confidence. We see the confidence, the coefficients values are very low, especially compared to the others. For instance,
Oh.
D3 times LPDI, okay, you get minus 1.2, compared to D4 times LPDI, where we get 0.04. We can see that actually external circumstances that we added as dummy variable do not impact as much the last quarter of the year as it impacts the first 1, 2, and 3 quarters.
Okay, so you all explained it in terms of the coefficient.
Yeah, I know we should not be, comparing the coefficients all like together because it depends actually on the variable, but the variables are the same. It's like still sales.
Yeah, but they,
Maybe we can.
yeah, after they, did you see all the stand arrows? This one is smaller, this one is smaller, and this one is also, although this is negative, okay? And the stand arrow, this is smaller too. This smaller, this is bigger, this is a little bit bigger, and this is bigger, then this is bigger. So after we consider the coefficient and stand arrow, what we see is all this t-statistic. So if we want to do the comparison, always see the t-statistic instead of coefficient. And that is what all this probability coming from. What does probability tell us? What is all this probability tell us? Is there any information from this probability? That's p-value, right? Right? Is there any information from the p-values? All of them is not significant. So what does that mean? Now what does that mean? If there's not total, there's all of them. Look at this one. From here to here, all of them are insignificant. Any information from there? Yes.
That when we add all these slope dummy variables all together in the model doesn't mean anything anymore. It's not accurate anymore.
Well, it's true. Okay, then what else? What else can you see from what you just say? We do have all the information is in the output. Not only, I just pointed out that you can see from the p-values, right?
The criterions too, they went up. The S squared actually went up too. So the S squared going up should be a good thing, but the Akaike Schwartz and Anakin criterions, they all went up too, which from the past equation.
Yeah, look at adjusted R squared here, okay, and adjusted R squared here. This one decrease. Really, adjusted R squared decrease, right?
We lost accuracy.
So it seems to us that all this personal disposable income and the confidence index doesn't relate it with the seasons. Our personal income is just like, whatever season, my personal income is like this. The confidence, it doesn't affect the season either. So in this case, maybe, this model is much more, is useful enough compared with the interaction terms. So not always, you have to do all the interaction terms. If they have, enough significant effect, then just forget it. So in this case, this one is much better in terms of all this criteria. We just learn it. Although in these questions, we still have to deal with Durbin-Watson statistics. The better Durbin-Watson statistics is about 2. Okay? But it really depends on the sample size. Now, we will learn this one in the next semester, all time series. Okay? And this is all, this is time series data again. Okay, I think this is all important for all of you, since we learned this slope dummy, and in our textbook it really didn't say much about what I said it here. So I added them to increase the usage of the slope dummy variable issues. Okay, and this is about 7.5, 7.4. Okay, slope dummy. Any questions about this one? Okay, and 7.4 is talking about the problems with incorrect functional form. What happens if we have incorrect functional form? Okay, and this telling us that if you have incorrect functional form, for example, would you like to see the diagram figure 7.6? 7.6. Let me see whether I have it in this output in here. Let me see whether I have it. Okay. Okay, I have the diagram. Okay, problem with the incorrect functional form. Look at the first one. This is double log. So usually double log is look like this way. Okay, if we have the beta, it's less than 0. It's like this way. And this dots is the data. But they pointed out if I have some data which is out of sample, means that they're working with those data, but they save some data. They're just using the original data up to here to do the analysis. Okay, so actually the original data is somewhere, included somewhere here, but they are using just up to here to do the functional form, and they are using this double log. So if I use the double log to be the functional form, then look at this one. Those data which is out of the sample, if this function is correct, okay, then usually out of the sample can also, this parts can become the forecasting. Okay, become the forecasting. So if my equation is like this one, and my forecasting is all on the curve, right? And those dot is my original variables, or original observations. So the deviation from the lines will be the forecasting error. Okay, so if I have the double log, look at this. This is my forecasting error. And if I have polynomial, my original data is like this one, and I find out this is a polynomial, then the forecasting for polynomial in this area will be something like here, but the original data is here. So the forecasting error is bigger. This is what the diagram likes to show. Okay? Then if this is semi-log. Okay, then if my original data is like this one, and I use this parts to as my sample, then I'm forecasting this one. So this parts will be a forecasting arrow, and this one to linear. And this is the original data, but I'm using original data, this parts to my forecasting. So I end up with the linear forecasting model. So this size, the forecasting arrow is bigger. So in other words, they are trying to say that if we have the incorrect functional form, the forecasting arrow is become bigger. Okay, and for the usage of the regression, there are three usage of the regression analysis. One is descriptive analysis. The second one is do the hypothesis testing, just like what we have done so far. The third one is for forecasting. Usually, the forecasting is for time series data. Okay, so for this method, we really didn't talk about the forecasting. So if we have an incorrect functional form, most of the time the forecasting error is big. And if we have the forecasting, if your purpose is for forecasting, and the incorrect functional form made a big mistakes. Okay, this is all about chapter 7. Okay, I'm done with that. And I already haven't explained the economic lab number 4 yet. So why don't we save the next week? Okay, we do it the lab number 4. You can do it lab number 4 in the class. So you can ask questions, okay, and I do some explanation of the lab number 4. Then we turn in January the 5th, which is the last class of this semester, and do the presentation. Okay, does that work? Well? Okay. So you will have the good Christmas, you will have the good Happy New Year, right? Okay, that's for today. Okay.